lecture 4 part 2. In this lesson we will take another example to find the deflection by Castiglione method. Example: determine the vertical displacement at point C of the beam shown in figure below. The modulus of elasticity E is equal to 200 times 10 to the power 6, and the moment of inertia is equal to 150 times 10 to the power 6 for the entire beam. At point C, we have load 20 kilonewton. So we will setting B equal to 20 kilonewton. Then we will find the reaction at the support by applying static equation sigma fx equal to 0, sigma fy equal to 0, sigma m at the support equal to 0. Then you can find the reaction at support A and the reaction at support B as shown in the figure. Now we will divide the beam in two segments, x1 and x2. For x1, we will take moment at point O, the reaction at support A 24 plus 0.5 p times the distance x1, the form load 8 times x1, and the distance will be x1 over 2 plus m1 equal to 0. Then we will take partial derivatives to m1 with respect to p, and it will be 0.5 x1. Now we setting p is equal to 0 is equal 20. It is actual value at C. So m1 will be 34 x1 minus 4 x1 to the power 2. For x2, for the same procedure, we will take moment at point O and then the support at point P 8 plus 0.5 p, the distance x2 positive, and the moment m2 counterclockwise will be negative as shown in the equation, equal to 0. Then m2 will be 8 plus 0.5 p times x2. We'll take the partial derivatives for m2 with respect to b, and will be 0.5 x2. Setting p equal to 20, then we will find m2. as we will see in this question. M2 is equal to 18x2. Now we will apply the equations to find the deflection at point C for the two bars x1 and x2. The limit for the x1 from 0 to 4 and the limits for the x2 from 0 to 4. After we make the integration for the both segments, we will find the deflection at point C equal to 14.2 millimeter. Now we will apply the method to determine the slope at the frame as shown in the example. Example, determine the slope at point C of the two-member frame shown in figure below. The modulus of elasticity E is equal to 200 times 10 to the power 6, and the moment of inertia is equal to 235 times 10 to the power 6. Point A is fixed. We will apply moment M dash at the point C, the point where we want to find the slope at. Then we will divide the frames in two segments, x1 and x2. For the x1, we will take counter clockwise as positive, sigma m at O equal to 0. So the equation will be minus m minus m dash for the uniform load 30 x1, the distance, times x1 over 2. This will equal to 0. Then we can find m1. We will take the partial derivatives for m1 with respect to m dash, and it will be minus 1. Now as before, we will setting m dash equal to 0. We will find m1 equal to minus 15x1 to the power 2. For the x2, we will take m moment at point O equal to 0. Then we will find the value of the moment m2 by applying the equations of static at point O. m2 will be minus 108. The distance will be x2 cosine 60 plus 1.8 minus m dash. We will take partial derivatives for m2 with respect to m dash, and it will be minus 1. Setting m dash equal to 0, m2 will be minus 108 times x2 cosine 60 plus 1.8. This is 1.8, the half distance for 3.6 meter. Then we will apply Castiglione equations to find the rotation at point C for two segment x1 and x2, the limit for x1 from 0 to L, for x2 from 0 to 3, for x1 from 0 to 3.6. We'll take the integration for both segment, and we will find that the rotation at point C will equal to 0.0225 radius. Thank you.